Factor. All right, can you guys factor that one? Actually, you can do that one without any tips. Okay, so we write the bow tie.
I think because you have to simplify to that.
I don't know if the words.
Yeah, you just parentheses and.
What's the number in the front?
It's X.
Yeah, so you put 1x, right? Remember, whatever's in front. You don't put x squared, huh?
No.
1x. And then you say, okay, what two numbers multiply to be 121, add to be 22. What times, so use your calculator. What times, you know what, one button we don't use a lot but will come in super handy in this section? Does anybody know? What could we do with that 121 to immediately find the numbers we need? Yeah, do you know that? Good job. That root button. Because if you hit the root, now that doesn't work on all the problems, but it pretty much will in this section for these first few ones. Because remember what square root says? What times itself is this thing? So what times itself is 121? Hit the square root button. 11. And that's your pair, right? 11 times 11 multiplies to be 121, adds to be 22.
Mr. Aaron.
Yeah.
I don't remember at all how to do a root. I don't remember.
Oh, that's with the calculator. That was just calculator. Yeah, just hit the square root button on your calculator on that. Yeah, I'm just doing that in the calculator. So that'd be 11 on that one. Oh.
My name's
Oh my God. Sorry.
Probably somewhere in these notes.
Thank you so much.
All right, so we good? So 11 and 11. Now, remember what we do? It's positive 11, positive 11. Now, remember, you take these two numbers. Bless you. Does anything go into 1x and 11? Nope. So just bring it down. How about over here? Anything go into 1x and 11? Nope. Bring it down. There it is. Now, what do we do when we have the exact same thing twice? That's identical twins there, right? What do we do when you have that? Yeah. You just put the 2 power, huh? And we don't need the 1 in front of the x. Just put the 2 power, and we're done.
Well, I just like, maybe can be.
Is that good? That easy? Nothing new there, really. Even though this is a new section, so far, that's old stuff. Right? That's all they want to see. Everybody good with the bow tie thing? Is that good?
Yeah, no, I seen one when you go from this one there, and you need to bring the other one. You know, how you call it? This answer we get,
Yeah.
we have to develop it where it come from. It's the same, no?
Do you mean like
parentheses?
if we multiplied it out, it would go back to that? Is that what you're saying?
Yeah, but if we see one from the beginning, it has x plus 11 squared.
Right.
It says develop, so we go down and break it down like how you call that, factorizing?
Oh well, we factored. If you the other way would be multiplying. So if we multiply this, it would go back.
Or
Factoring is reversible. Yeah, distributing is multiplying.
Okay, so if I find that one at the bottom, it said it's distributed. If I see that one on top, it's factoring.
Yeah.
Okay.
Yeah. Right. All right. Well, let's times the back number, right? So front number times the back, 16. And then the middle number goes here. And then you put the 16x and the 16x. Notice I didn't put the whole 16x squared, right? That's what's a little funny about the bow tie method. You just take x to the first power, don't you? Good? So we just take a 16x to the first. I multiply the numbers here, add the number there. So now I'm looking for two numbers that multiply to be 16. If you're not sure, if you're looking at them going, I don't know, then remember what you could do with a calculator? Remember how we learned? You can always use a calculator. Just take that 16, divide by 2, 3, 4, 5. You know, you can always just start with 2. 16 divided by 2 would be 8. And you think, okay, can 2 and 8 do it? No way 2 and 8 can make negative 8 on the bottom, huh? No way they can add to be, they'd be 10. So divide by 3, it doesn't even work to decimal. Divide by 4, you get 4. Could 4 and 4? That's the next part. Yeah. What? Now, what? Remember the signs. Who tells us the signs?
The
The bottom. Yeah. -8. Both negative, huh? Both negative. Or you could have done the trick I told you is always going to work on these first few in this section, which is what? Square root. It would have told you 4 right away. I'm telling you, that's the secret in this section, because they're going to make a match every time. So, and that won't always work in general. It doesn't work for all bow ties, but it will in this section. So, all right. So then -4, -4. Okay. Now, where do we go from here? How do we finish this problem up?
Dividing.
Yeah, we look at these two and we say, what goes into both of those? 4, huh? So we go divide by 4, divide by 4, bring it down. What is it? 4x minus 1? Is that good? Everybody making sense out of that? Remember all this? And then the next group, same kind of thing. Divide by 4, divide by 4. That 4 goes into both them also. Oh, yeah, that's right. We'd already learned, huh? I gave you a trick last time. I added my own little part to the Shelby special method bow tie. So whatever number you get here is always the number you divide over there, huh? I was very proud of my little observation. That was helpful. Whatever, that'll always work. Whatever number you get here, you put right there automatic. And this one's easy enough. You don't need that little trick. So then this becomes 4x. This becomes minus 1. Identical twins? So, squared. Got it. Is that good? We're good, right? All right. So that's really not new. We're going to get to new stuff. That's not new. That's just kind of a review. Let's reorder. Highest power first. And then the one at the back. Yeah.
Yeah, the 20 yeah, this is prime.
Okay, so what goes in the front of each of these? Remember, you've got to take that power and cut it in half.
X squared.
X squared, right? You see how we always cut that in half? Normally it's x squared in the front, so we go regular x, huh? But what we're really doing is cutting in half. So yeah, x squared. And then you multiply what numbers in the front? 1 times 1.
1.
And the bottom, 10. So what two numbers do you know that multiply to be 1? What times what is 1? 1 times 1. That's the only thing I know that multiplies to be only whole numbers that multiply to be 1. Do they add to be 10? Not even close. Not factorable. This one can't be done. They call that prime. Prime means you can't factor, you can't break it down. It's already as broken down as it'll get. So that one's prime. Yeah.
I did one that, I tried to make one that was prime and take me like 30 minutes, 45 minutes to find out that it don't go through. So you just go like that. If I multiply and don't add, it's prime. Right?
Right. Yeah, that's right. If there's no numbers that'll multiply and add, then it's prime. Exactly. Yeah.
Okay, let's say it were 10x. Okay. If you just add a 0 too, so it will be 10 in the bottom 100.
So are you trying to make up some that work? Is that what you're trying to do?
No, that's fine. I understand now that yeah, because the other one is example, it can be factorable.
Yeah. So it's if there's no combos that work, it's not factorable. It's prime. Yeah, I know. Try not to. Yeah, I know those can waste time, huh? Okay, so now we're factoring 9 minus 16x squared.
That's number 6.
This one's a little different.
Yeah.
What's different about this one?
The number.
It's only got 2 terms, huh?
Yeah. And when you develop it, you leave the number in the same order.
Yeah, you already did some of these? Yeah. That's right. Yeah, so first, let me say a couple of things. So there's a first observation. There's only 2 terms, right? Everything else we've been doing for a while. See 3 terms? right? Go back to the other one, 3 terms. See, they normally have 3 terms. They're normally trinomials. This is a binomial, 2-termer. So first off, it's only got 2 terms. These are going to be the easiest of all. These are going to be your favorite factoring problems. There's only 2 terms. Do not reorder. Do not reorder. We only reorder when there's 3 terms. There's some specific reasons for that, but let's don't get into all that right now. To make things simple, let me just say don't reorder 2-termers. Only reorder 3-termers. So there's 2 terms. We leave them. We don't reorder them. What do? How do we factor? You basically do the 2. I'm going to jump right to the answer. I'm not going to write the diamond. I'm not going to write the bow tie. I'm going to go straight to the answer. These are going to be the quickest of all. How do you do it? You just write the parentheses.
3 times 3?
Yeah, and you just think, what in the front times what in the front will make the front?
Yeah.
Front times front to make front. What times what makes 9?
3.
3 times 3. And then what in the back times what in the back makes the back. What times what is 16x squared?
4.
4x, 4x, right? 4x times 4x is 16x squared.
Yes.
Remember, because the 1 powers add to make it x squared there. Now, how are you going to make negative 16x squared? What signs, how do you have 2 things multiply, come out negative? 1 positive, 1 negative. Either order, you can put the negative first and the positive, vice versa.
Or 1 negative.
Doesn't matter at all, we're done. That's it. That's all there is. Nothing more needed.
How you call it, binomials? Binomials?
Binomial, yeah, we just factored it. Two-termer.
I tried to get the word in English, binomial.
Yeah, like bicycle. 2, bi is 2.
Right.
Yeah. So like 2 tires, bicycle, binomial, 2 terms. Yeah, and that's it. You don't have to mess with the bow tie. You don't have to mess with the diamond. You don't have to do anything like that. Just like that. Hey, let's check it. We're done. You don't have to do this, but I want to show you why it works. You know what it is? What if you foiled it out? Let's just foil it out to show that it works. Show that it's true. So you'd get 9 minus 12x. And then this one would go to both. Plus 12x minus 16 squared. See what would happen with these guys in the middle? What would they do? They cancel. That's why there's no middle. That's why there's no 3rd term. It's actually just 0 in the middle. That's what it is.
Yep.
We good? All right. So let's start by factoring now. Whenever you factor, what's the first step in every factoring problem? GCF, right? We can't ever forget that. Is there a GCF? Is there something that all the terms share in common? Because you have to do that first before you do bow tie or any of the other methods.
X and Y.
Yeah. What do you? Do they both have an X and they both have a Y? Don't they? So do that first. Take out the GCF, and that always just has 1 parenthesis, not 2, huh? You do that first, and then second, you do your other things that have the 2 parentheses. And you leave the GCF in the front. You with me? So step 1, GCF 1 parenthesis. Step 2, you'll break that 1 parenthesis into 2. Good, so do that first. I'll give you okay, we ready? So do you remember GCF? It's been about a week or so since you've done GCF. So you look at these 2 and you say, what do they both have?
No.
They both have X's and Y's. You take out the lowest X and the lowest Y. And you do 1 parenthesis, not 2. Don't go right away to 2. Is everybody seeing what I'm saying? Is everybody?
Cancel out, right? And then we are left with negative.
Everybody smelling what I'm stepping in? That's the Southern saying, right? Isn't that great? That's in the South. That's what they say in the South. At least I heard somebody from the South say that once. Are you tracking with me? Are you smelling what I'm stepping in? Are you good? You tracking with me close? I like that saying. It's got real feel to it. All right. So you good? You tracking? So you put one parenthesis,
minus 16.
and then you put inside whatever
So
works.
this is squared.
xy times what would go back to x cubed y.
So you just need
X
one
second, huh?
right?
And then xy times what would go back to this.
And then the other side would just be
Minus
positive.
16y squared.
Oh, okay, you go from here, bring this down.
We good to there?
Break it again?
So that's step one. And now step two, you leave the xy sitting in the front, right? The GCF is still in the front.
Perfect square.
And now we're going to do two
One
parentheses.
has to be negative, one has to be positive, but they're both looking exactly the same.
We go from 1 to 2.
Just one negative, one positive.
This making sense? Now this is a
Factor,
binomial.
and then just bring that down.
Binomial.
And then you just find the square root of that and the square root of that, which is square root of that.
So we good?
On one side.
So what times what is x squared?
Okay.
X times x. Remember how we do the binomial? In fact, you know what? We're going to do the triple today too. So let me help. You know what? I think of them this way. Here's a way that might help. I heard Shelby saying the square root thing. That's a good idea. Let's think about it that way. X squared is really x times x, isn't it?
Yeah.
It's something twice. We call that a square in math. Square means 2. Okay, now 16y squared is also a square. I don't just mean the y is squared. I mean the entire 16y squared is something twice. What twice? What times what? What times itself is 16y squared? 4y, 4y. Right, you with me? I call this a double-double. I like In-N-Out Burger. Double-double.
Oh, yeah.
Double-double.
Give me one after.
So I'm going to start calling it that. We're gonna do a lot of these tonight. So it's a double-double. Okay. So what do you do when you see something twice, something twice? That's what this is, right? Something twice, something twice. You just take the two items on the left and you go left, left. The two items from the right and you go right, right. Let's do that. So I take the two items on the left, XX, two items on the right, 4y, 4y. And then what goes in the middle between them? How do you get negative? One's a positive, one's a negative. Doesn't matter what order. As long as you have one positive, one negative. Done. So that's how we always handle what I call double-double. It's formally called difference of squares. So difference of squares. So I want to give you the official word. So that's difference of squares because this was a subtraction, a difference of two things that were squares, something twice. Square is math's way of saying double. We good? And we're done with that one. So see how the progress went on that one. So first step is GCF with one parenthesis, not two. We don't go to the two right away, right? Second step, the double-double breaks into two. No bow tie needed. So double-double, you just break it into two. Left, left, right, right, 1 plus 1 minus. Does that make sense? We good? So this is a new technique of factoring. This is all going to be on the exam. When's our exam? 2 weeks from today? Yeah. 2 weeks from today. I just made your exam a couple days ago, so I know it's all on there. Why? I need to get things ready. Okay, so first step. So what is the first step? It's always GCF. I mean, if there is a GCF, with one parenthesis. So use your calculator. You'll find 3 goes into both those, right? So you put 3, 1 parenthesis. Everybody tracking with me? Everybody smelling what I'm stepping in? I like that. I'm going to keep using it. It's helpful when you're eating snacks, especially. So you put a 3 in the front. 3 times what is 75x squared? 25. Yeah, use your calculator. 25x squared. That's a funny looking 5 there. And 3 times minus 4. Good so far. So if there is a GCF, we have to do that first with one parenthesis. Right? Just like the last problem. Right? They had XY in common. So I had to do that first. See how my first line had 1 parenthesis, then I went to the 2 afterwards? Now, why didn't I do that back on number 6? Why on number 6 did I just go straight to the 2 parentheses and done? Because they had no GCF. There was nothing goes into 9 and 16 evenly, right?
Yeah.
You see the difference? Everybody tracking with me? Okay. So now that I've got that 3 out, how do I go further? What is 20? What is 2? What do we think when we see 2 terms? What do we look for when we see 2 terms? We see 3 terms, we do bow tie. Right? 3 terms is bow tie. But I'm looking at 2 terms, right? The 3 is done. He's out. I'm looking at these 2 terms now. So you want to start thinking, because on the test, they're all mixed up. There's about 4 problems there are exactly 4 problems from every section. We have 5 sections on this test. 4 problems from each section, 20 questions. So they're all mixed up. So you want to focus on the number of terms will tell you what to try. If you have 3 terms, you do the bow tie thing. If you have 2 terms, what's the only thing we do with 2 terms? Double-double. So you just want to look at, now is that a double-double? It is. It is. It's 5x times 5. So I don't just mean the 25. I mean the whole 25x squared is 5x, 5x, right? And the 4 is 2 times 2. It's double-double. Look at that. Right? So what? Well, that means the 3 just stays out there. That means 2 parentheses. And you take these 2 5x's on the left, and you go left, left. Take the 2 2's on the right, and go right, right. And what goes in the middle? You got to make it -4. So 1 plus, 1 minus. Either order, doesn't matter. Done. See, the double-double is the quickest factor. Everybody see that? So first step is always GCF if there is something in common. 1 parenthesis. And then you look at what you got. If you got 2 terms, think about double-double. If you got 3 terms, think about bow tie. We got 2 terms, double-double. 5x, 5x, 2, 2. Left, left, right, right. 1 plus, 1 minus.
In the computer, we have to put GCF inside a parenthesis?
No. Nope, just like that. Computer will take it just like that. We good? Are we happy? I'm happy if you're happy. And you're happy if you know. First step on every factoring problem. GCF. Look for GCF. Is there a GCF here? No. There's nothing in common, huh? Nothing goes into 4 and 49. They don't both have an x, right? The 4x squared has an x, but the 49 doesn't. So there's nothing in common. There's no GCF. Okay, so skip that. So we're going to skip the 1 parenthesis step, right? Skip the 1 parenthesis step. When Shelby sees what you did to her sheet, she's going to be so mad. I mean, really mad. It's not okay, Shelby. Call the math police right away. All right. So we jump right into double-double. It's 2 terms. So I'm not even thinking about bow tie. I'm just thinking 2 terms, double-double. Is it a double-double? Absolutely. What is it? 2x, 2x, and 7, 7. So 2 parentheses, left, left, right, right, 1 plus 1 minus, done. Double-double is our friend. There it is. Double-double is not the friend of your cholesterol level. Double-double is good for factoring. All right. Good? So there was no GCF on that one. That's why that was different. We didn't have the 1 parenthesis step first. Went right to the 2. Okay. Simple, but they're blowing it up bigger to confuse you, to see if your eye can follow the pattern even when they make it bigger. What pattern am I talking about? Well, first off, how many terms? Because remember, if you're looking at 2 terms, you want to think maybe it's double-double. That's all we have so far for 2 terms, double-double. If you're looking at 3 terms, then you want to do bow tie, right? So, and our first step is GCF. Is there anything in common? No. All right. There's nothing in common. There's no number they all have. They don't all have an X. Nothing in common. Okay, GCF's over, but we do need to look for that. Second, are there 2 terms there or 3? Now, you got to know what I mean by terms. There's 2. Terms are things said. It's the only word I'm into. Really, I'm not into the verbiage. You probably see. I make up my own names, double-double and stuff. I don't see the big value of speaking math. Who cares? But there is one word that's useful. That'll really help you solve problems. And that is terms. Knowing what they mean by terms. That's the word that'll help you. Why? Terms are things separated by pluses and minuses outside of parentheses. Meaning this and this. That's a Y there. That's the separator. That's the only separator. The loose horse. You know, the uncorralled plus or minus. That'll help you know how to look at the problem and what to do with it. Those are the two terms. The separators are the pluses and minuses not in parentheses. So that's how you want to visualize it. That's a two-term problem. This is all one term. Why? It's all parenthesized together. One term, second term. Two terms. That's how you want to look at it. Now, what does that do for me? Well, that tells me it's two terms. So I'm not thinking bow tie. What's the only thing we do so far with two terms? Double-double. Is that a double-double?
Yeah.
Absolutely. It's just a big fancy one. See how it's just a little bigger than normal?
So you don't consider that three terms because the first one is dubbed like two?
Because it's in parentheses. It's grouped as one.
Yeah.
It's those parentheses that say, nope, we hang together. We're one.
And that's easy for
Yeah. So that's two terms. Everybody see what I'm saying there? So then it's two terms. It's double-double. So what do you always do with double-double? You write the double-double. X plus 3, parentheses, x plus 3y, parentheses, x plus 3y. And what's the double for 64? 8 times 8.
8 times 8, yeah.
See how it's a double-double? Double-double. Now what do we do? What's the pattern? Let me go over here and really clearly write for you the factoring pattern. Now let's just call it x squared minus w squared. What do? You do two parentheses, you go x, x, w, w, 1 plus 1 minus. That's the general pattern we always follow for double-double. Let's do it here. Two parentheses. What's going to go in the left? One of these. Left, left, right, left, left, right, right. And what goes in the middle between them? 1 plus, 1 minus. Done. Game over. Do you see that? That's just the same. That's just a big double-double. But it's the same thing.
It's a 4 by 4. I was gonna say.
I've heard that's the limit. That's as much as they will serve you.
I think I've heard someone
Oh, they
order
have
like
a
a
triple,
6 by
no?
6 before.
Wow.
Oh, that's why I don't know what this is.
No, and then now this to the turn, no? 4?
All right, so we good there? You see that's just a big double-double?
No.
All right. And we're done. Okay. All right. It's all about, what's the first step? First step, GCF, there's none.
GCA.
You're good? There's no GCF here. Right? It's a good habit to always be looking for it right in the beginning. But no way. They don't all have an X. They don't all have a Y. There's not a number that they all have. There's no GCF. So no GCF. So I'm going to skip the one big parenthesis step. All right. So I'm going to move forward. Now, how many terms are we looking at? 4. Now, what are we going to do with that? We're used to 2 terms is double-double, 3 terms is bow tie. What do we do with 4 terms?
What kind again? No, factor, we got
We've done it. It's been about 2 weeks. Week and a half, 2 weeks. Yeah. Yeah, we broke it in half. We did first 2, last 2. That will not work on this one. But I want you to see it fail. Don't write this down. Watch it not work, and then we'll go back and talk about what will work. So I want you to see that the old way won't work on this one, and then I'll tell you how you know it, like how do I know right now, and how are you going to know, and then what do you do about it? So watch the old way fail. What was the old, remember we had 4 terms about a week and a half ago, 2 weeks? We did 2-2, we called it grouping. First 2, last 2. And we'd say, okay, what's in common to the first 2? What goes into x squared minus 16x?
X and Y.
No, just the first 2. Don't even look at the back 2.
8 and Y.
Just these first 2 right here. What do they have in common? Just those 2. X. Just x, right? Don't write this down. It's not going to work. Don't write it down, Manuel. Don't write it down. All right. So the first two, take out x. That looks good so far. It's going nowhere. All right, the last two. What do you do with the last two? What do they have in common? No, nothing. They don't both have a y. 64 doesn't have a y. See, we're stuck.
Oh, yeah.
Dead end straight. We're going nowhere. See how it doesn't work. 2-2 split doesn't work on this one. So let me write that. 2-2 split, no. It doesn't work. Okay, well then what are we going to do? That's what we did. That's what we did a week and a half, 2 weeks ago. We did 2-2 split. There's a couple of those on the exam. I picked them just the other day. I know that worked that way. This one, do you see those first three terms right there? These three are calling out, saying, we go well together. Let us three. Do a 3-1 split instead of a 2-2. Why? How do you know? How do you know those three are calling out, saying we go well together?
They have 8 and then I have x.
X squared, x, no x. We've seen that pattern a million times, huh? When you see x squared, x, no x, on the first three, put those together. So this is not going to be a 2-2 split. It's going to be a 3-1. Why? Because those first three go so well together. So on practice exam day, we'll do both kinds. We'll have some 4-termers that you do a 2-2 split, and some you do a 3-1. Both are possible. So you have to kind of develop an eye for seeing it. So this is a 3-1 because those three are x squared, x, no x, which is the form we always use. Okay, so now for a second, now that we have the game plan, let's carry it out. How are you going to deal with those first three? Pretend the whole problem is those first. Yeah, what do we do for 3 terms? Bow tie. So do bow tie on those first 3. Do bow tie. Now, forget about the minus y squared for now. Just do bow tie on those first 3, and then let's take a look. So, bow tie the first 3, right? So x, x, and you multiply the front times the back, so that's 64 minus 16. So remember what I've been telling you tonight about how to find the two numbers? Square root that number in the top, you get 8. So these are going to be 8 and 8. What signs do we need to make them add to be negative 16? Minus 8, right? They add to be minus 16. Okay, so what does that give us? These two, nothing divides into x and minus 8, so it's just x minus 8. These two, same thing, x minus 8. Now, we're not done. That's just for these first 3 to bring down the minus y squared. We good? To there so far. Are we good? So I did those first 3. I bow tied those first 3. X minus 8, x minus 8. Bring down the minus y squared. Now, what do we do now?
We add that one to the other side.
How many terms are we looking at on this line? How many terms? It's all about terms, right? Because if you're looking at 2 terms, you should be thinking double-double. If you're looking at 3 terms, you should be doing bow tie. If you're looking at 4 terms, then you got to split it up somehow. How many terms on this line? You need to know the answer to that question. How many terms?
Therefore,
Terms are separated from each other by what?
by parentheses.
This guy. Only this guy.
Oh.
Pluses and minuses outside of parentheses, right? Loose horses, I always call them. They're not corralled. So that's the separator. There's 2 terms there. That tells you, I'm not into the words, but it tells you how to look at it. You should be looking at it like this is 1 term. You think, yeah, but it's 2 things. Whatever. It's 1 term. There's no separation there, and that's the second term. That's how you should be looking at it. That'll help you know what to do. 2 terms. That's the only separator. Now, 2 terms. What's the only thing I ever look for when I'm looking at 2 terms? The only thing I ever look for with 2 terms is one of my favorite restaurants, Double Double, In-N-Out Burger. Double Double. That's all we do with 2 terms. For now. In a minute, we're going to do triple triple. But for now, Double-double. Double-double. So is that a double-double? Is this a double? Is this something twice, something twice? Absolutely. That's why. That's clearly something twice, isn't it? Yeah, that's a double-double, for sure. So what do we do when you got double-double? Put big old parenthesis, left, right, 1 plus, 1 minus, game over. Right? Everybody see that conclusion? Did you notice it's plus y minus y? Because that's always what you do with double. You got to get minus y squared, huh? So positive y times negative y means minus y squared, huh? See how that was just a big fancy double-double? Do you see what I mean by the patterns? Right? I could draw it with triangles. I hope you won't think it's kindergarten or something. I'm not meaning to put you down. I'm wanting to show you how clearly you can see the pattern in several different ways. If I go triangle squared minus box squared, it's not kindergarten. I'm just trying to make it really, really clear. It's 2 parentheses, triangle, right, left, right, 1 plus, 1 minus. My box, I know my... See, I didn't learn to draw my shapes in kindergarten. That's the problem. You got the idea, right? It's that simple. It really is. They just, what they do, that is the concept. The concept is absolutely that simple. That is the pattern. They just make it bigger. And then all of a sudden, our eye loses focus. Well, that's what you want to train yourself to do better. That's mathematical thinking. As you move up the line in math, you get better and better at looking at something like this and saying, I don't care that it's big, and it's got parentheses, whatever. It's just like triangle squared. It's something twice. Something twice. Something twice, something twice. You go left, right, 1 plus 1 minus, done. And you can handle that pattern when they try to throw you off by making it bigger. That's mathematical thinking. It's pattern thinking. Does that make sense? That's what they're trying to develop in you, really. Like, what is all this math class about? You going to do algebra in your job? Probably not, unless you're becoming a scientist or an engineer. Probably not. You won't be doing this. But you are being trained more and more to recognize patterns, describe patterns, predict patterns, which is what a lot of fields do. What does a lawyer do? Looks for patterns in the law. He reads laws, writes laws, argues, tries to follow a pattern in the law. What does a doctor do? Looks for patterns in your symptoms, right? I mean, a lot of life is patternistic, logical thinking. That's really what math is. That's the heartbeat of math. Pattern.
Right now they're using the logarithm.
Anytime you see double-double.
What is it?
Yeah, so if the first 3 go well together, by go well together, I mean x squared, x no x, then bow tie those 3. Yeah. If the first 3 are not x, like if there was something like, say there was a y here or something, then I would not have done those first 3 together. Because that would have been messed up. We need x squared, x no x to do that together. All right, we better try to spend a long time on that. All right, so are we ready to dive in? So it's 2 to first off GCF. Is there something in common? No way. They don't both have an x. They don't both have a number. No GCF. Okay, how many terms are we looking at?
2.
2 terms. What's the only thing we ever do with 2 terms so far? Double-double. Is that a double-double? Absolutely. It's x squared, x squared. Use your calculator. Square root of 256 will tell you 16, huh? 16 times 16. So yeah, it's a double-double. Now notice, I haven't been making any big deal about the sign up to now because it just didn't want to give you too much to worry about. It's got a minus in the middle, huh? It must have a minus in the middle. Double-double with plus in the middle will not break down. Let me write a note over there. Double-double only works with minus in the middle. Plus in the middle does nothing. Or does not break down. Is that more helpful? Does not break down. What am I talking about? If there was a plus in the middle here, I would stop and say not factorable. Plus in the middle wrecks double-double. It's not factorable. But anyway, they didn't give me plus. They gave me minus, so I can do it. So let's do it. What do? 2 parentheses. Left, left. Right, right. 1 plus 1 minus, because positive times negative is negative. Good so far? Now, this is another double-double here, right? This is XX 4, 4. So that one's going to break down. But the other one, the x squared plus 16, that one cannot break down. It's going to be part of the answer. It's just not changing.
Oh, okay.
Because it's got the plus. It has to stay as is. Plus double-double cannot. This is a great common mistake, often made. XX, 4, 4, 1 plus 1 minus, done. Now, does everybody see what happened there? So this guy broke into these two, but the front one stayed as it was. Why? Because he's got a plus.
Okay, Mr. So we need to keep broken down.
As far as we can go. Whenever we have another double, no. You might wonder, why can't we do it again? You know, XX2, 2. No, that's not x squared.
No.
That's not a double. And that's not a double. And that has plus, so he can't go anywhere, so we're done. If this was x squared minus 4, I would go again. I'd go x plus 2x minus 2.
Because what I did, I went from the 2 parentheses down, I went to 4 parentheses.
Right, because you thought this one broke into 2.
Yes.
Right, so does everybody see? I'm going to give the reason why, but I want you to first off see the fact that it doesn't break down. The plus double-double stays as it is. You might think, well, isn't it x plus 4, x plus 4? No. I want to prove to you it's not in great detail in just a second. But first off, let me just tell you, it is not x plus 4, x plus 4. That's simply not true, which we'll see in a minute. That would give you a plus 8x in the middle. It's not x plus 4, x plus 4. I'll show you in a minute. So it has to stay as it is. But x squared minus 16, that one breaks down. So only minus double-doubles break down. Only double-doubles with minus in the middle can break down. Is that making sense? Are you tracking with me?
Why not minus 4?
So this is the final answer, the 3.
It'd make minus 8x in the middle. I'll show you. I'm gonna do all the detail. But that's our final answer. So one more time. Anytime you have a double-double, you need to go again and again and again and again until you're all done. How do you know when you're all done? Well, these guys are all done because the x is not squared anymore. So it's not a double. And this guy's done because he's plus. So we're done. Nothing can go further. Do y'all see that? Is that making sense? Well, there is one just like this on the exam. I remember picking it. For half a grade. 5%. They're all 5%. 20 questions times 5 is 100. So they're all 5%. So you got that? That'll be half a grade in a week. Do you know how to do that? Is that making sense? All done? Is that good? All right. So let me prove to you, because you might think it'd be natural. I would have too. I'm sure I did first time. I would think, what? No, can't we just make that x plus 4, x plus 4? No, let's prove it's not true. Let me just do it. Let me just FOIL that. If that was really true, then if I multiplied it out, it would have to go back. It doesn't. Watch. X squared plus 4x plus 4x plus 16. See what it becomes? 4x and 4x? 8x. No, this is not x squared plus 8x plus 16. See, you got that 8x in the middle, proving that's not right. It's not x plus 4x plus 4, is it? And you might think, well, make them both minus. Make them both minus. All that's going to do is make both these guys minus. Then you're going to have minus 8x in the middle. That's still not x squared plus 16. You think, well, you see, the only way you're going to get rid of the 4x's in the middle is to have one of them be plus and one of them be minus, because then you'll get a plus 4x and a minus 4x, and they'll cancel, right? But then positive times negative is negative. That's why only the negative works. There's no way to make it work with positive 16. That sign in the middle makes all the difference in the world, doesn't it? For double-double. But we're about to go to triple-triple. And on triple-triple, both plus and minus work. It's a different story. So for double-double, only minus works. For triple-triple, both work. Good? You tracking with all these turns in the plot here?
I need the process clean.
We good? Questions on that one? All right. So we're done with that one. Only double-double minus works. So remember that rule. Only double-double minus. Triple-triple plus. Can't do it. Time. W cubed minus 64.
Oh, that's what we do.
So, is that, first off, is that a triple-triple? Well, yeah, that's 3, that's WWW. And what about 64? Is that a triple? Is there a number times it? So just take your calculator and guess. Take 5 times 5 times 5. And you go, oh, that's too big. 4 times 4 times 4. Yep, there it is. So it's 4 times 4. No cheating. Did Shelby give away the secret? Is it on there? Oh my goodness.
Yeah, thank you.
Look at that.
Go to the cube.
There they are. Look at those cubes down there for you. Nice. Yeah, and see? Yeah, look at her handout. Here we go. Yeah, it's 4 times 4 times 4. You've got the example there on the sheet. Shelby's telling you how to do it. So what's it going to be? A triple-triple is a little parenthesis and a big. You might think it's like 3 parentheses or something, but it's not. It's one little parenthesis that has 2 things in it, and a big parenthesis that has 3 things. Now I'm going to give you the pattern. You know what you could do? Here's a way to help you with the pattern. Basically, it'll go like this. You have 3. When you have a triple-triple, you have 3 items. One of the items on the left will go left. One of the items on the right will go on the right. So 1 left, 1 right. And then 2 of the items on the left will go left. That's W times W, W squared. And the other 2 items on the right will go on the right. 4 times 4? 16. So far, so good? So what am I doing? I'm doing 1 left, 1 right, 2 left, 2 right. See the pattern so far? We're not done yet. 1 of the left items on the left, 1 of the right items on the right. 1 left, 1 right. 2 left, 2 right. So see how the left stuff is always going left, the right stuff is always going right in these parentheses? 1 left, so 1 left, 1 right, 2 left, 2 right. And what goes in the middle? You might think, well, we're all done. They're all gone. Yeah, I know. I'm just using an analogy. 1 of each. In the middle goes 1 of each. 1 of these guys and 1 of these guys. 4 W. No signs yet. Notice I haven't put any pluses or minuses. Did Shelby tell you the secret? Yeah, there's no secret on there. There's a certain memory device for the signs. Does anybody know it? So I haven't put any plus or minuses yet.
It is, if you start with minus there,
Yeah?
the outside is minus and the big one is plus.
How do you know? Oh, you're just looking at the sheet there? The wrinkled sheet?
Yeah. That's the sheet.
Yeah, we'll just keep it at that.
Clean,
The sheet.
Nice.
The nice, clean sheet, yes. Yeah, there's a memory device to help you. This is how I survived college. I have a terrible memory. I need memory devices for everything. What's nobody knows it?
The first term is minus.
What is it?
The sign in the front goes with the first parenthesis.
Right.
The second is
There's you're right. You're totally right. But there's a Shelby, you want to say it for us?
Oh,
Do you know the word? There's a special word.
The
Soap.
difference, the sum of difference.
Oh, I haven't heard of it.
Oh, okay.
Oh,
Wow, I've got one that Shelby has to read. Soap the signs. Soap the signs. What do I mean, soap the signs? Whatever sign you started with, same as what you started with, opposite of what you started with. At AP, always positive at the back. Always positive. Soap the signs. Same opposite, always positive. So whatever sign you start with, it's the same. Then it's the opposite of what you started with, and it's always positive at the back. And we're done. That's how you do triple, triple. So what's the pattern for triple, triple? One left, one right. Two left, two right. One of each in the middle. Soap the signs.
Always positive.
Always. Look at what she has in her sheet. See how the one at the back is always positive? Both those cases.
Okay, so the same.
Same opposite.
Opposite.
Always positive. Soap those
Just
signs.
find these little patterns within to help you.
That's right.
Wow.
I just can't see why everybody doesn't just get an A in my classes. That's all right there. There it is. Is that good? Is that making sense? Shall we try another one of those?
Yes. Always positive. What you get? What you get for?
Okay, let's try again. You ready?
Because these two.
I think we need a couple more times seeing the pattern laid out. We ready? So you want to write it X, 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 and what is 8? What times itself 3 times is 8? 2, 2, 2. Multiply, right? 2 times 2 is 4 times 2 is 8. So you see it's a triple, triple. What do you do when you see triple, triple? Little parenthesis and a big. Little parenthesis and a big. Now, one of the items from the left goes on the left. One of the items from the right goes on the right. One left, one right. 2 left, x squared. 2 right, 2 times 2, 4. And one of each in the middle, 2x. Did you track that? So let me show that again. So it's always 2 items and 3 items, little parenthesis big. So remember, we're always doing left stuff to the left, right stuff to the right. 1 left, 1 right. 2 left, 2 right.
That makes sense.
One of each in the middle. Does that make sense? So again, it's 1 left, 1 right, 2 left, 2 right, one of each in the middle. So 1 left. So no, yeah, one way you could write it. Here's one way you could write it. You could say left times left, right times right. You know, 1 left, 1 right, 2 left, 2 right, and in the middle, one of each. And then what do we do for the signs? Soap them, right? Soap the signs. Start with the whatever. It's all based on what you started with. We started with plus, so you do the same. Opposite. Well, it's always positive. Same opposite, always positive, and we're done. So it's 1 left, 1 right, 2 left, 2 right, one of each in the middle. Is that making sense? We good with triple, triple? Want to try another one? I want to do a couple of these basic ones. Make sure you're good before we do that. They're going to throw in GCFs and harder stuff. So let's try another one. How about y cubed minus 20. So I'm just making up examples because I don't want to dive into the harder ones yet. I want to make sure we're all able to do these. So let's try x cubed minus 27.
We need to do.
Okay. So triple, triple. 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. Triple, triple. What do you do when you see triple, triple? You freak out. No. Little parenthesis and a big. Little parenthesis and a big.
Oh my god.
Okay. 1 left. Let me get the right color here. 1 left, 1 right. One of the left items left, one of the right items right. 2 left, 2 right. 3 times 3? 9. So 1 left, 1 right. 2 left, 2 right. What goes in the middle? 1 of each. A 3 and a y. And now, what are the signs? S-O-A-P. What did we start with? Negative? Same as what we started with? Opposite of what we started with? Always positive at the back. Done. Is that making sense? It's getting easier?
Not as easy, but we got getting on it.
All right. Now, let me do one more before I go back to their homework. What if I give you 8x cubed plus 125? All right. Let's try that one. So definitely write that first one as a triple. Let's see it. So it's important to write the triple. So this is, remember, you want to write this 8x to the third as 3 items. So 2x, 2x, 2x. Everybody track with me? Don't write 2, 2, 2, x, 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 because that's 6 items. That's not 3 items. That's not a triple. That's a, whatever the word for sextile is, whatever that is. It's not that. You got to write it as 3 things, and then the 125 is 555. You with me? Triple. We need to see it as 3 things, 3 things. Then we put a little parenthesis and a big, and we go 1 left. Now I encourage you to underline them, circle them, do something to focus yourself on them. 1 left, 1 right. Good so far?
1 left and right.
2 left. What's 2x, 2x? 4x squared. 2 right. 5 times 5, 25. Everybody seeing how I'm coming up with those? And in the middle, 1 of each. 2x times 5, 10x. Everybody track with that. Right? You make it 3 things, 3 things. 1 left, 1 right. 2 left, 2x, 2x, 4x squared. 2 right, 1 of each in the middle. And then, what do you do for the signs? You soap them. S-O-A-P. What did you start with? Started with plus, same as what you started with. Opposite of what you started with. Always positive at the back. There it is. All right, you ready to go back to the exercises? Is that good? You feel solid on the triples? Now they're going to mix in the triples with GCFs and things like that. None of these have had GCFs. 8 and 125 had nothing in common. This is just the beginning of Math 63. It gets much more complex than this. Much more. 63 is for sure a big step up from 61. So you should be looking at 1 term, 2 terms. That's how you should be looking at that thing. The minus is the separator, huh?
No.
2 terms.
No. But to get this one here.
Okay, so what do they both have?
Here and right again.
Y squared. So first the GCF with the 1 parenthesis. What does that leave on the inside?
Wait, they only have y squared something.
X cubed minus 1.
It's gonna go y squared.
Everybody see that? Y squared times x cubed and y squared times 1
And you're gonna.
would go back, wouldn't it?
Are the others?
So now, how do you get it?
1 is the cube root of itself. So it's 1 times 1 times 1.
Okay, so we leave
Right?
the y squared in the front.
One of these goes here, one of those go there.
So we just leave the y squared sitting there. I'm going to take this x cubed minus 1. I'm going to make little parenthesis and a big y.
Minus 1.
Because he's a triple, isn't he? Does everybody see that? That's x times x times x. And 1 is 1 times 1 times 1.
1x.
And then 2.
It's a triple. What do we always do for a triple? 1 left, 1 right. 2 left, 2 right. 1 times 1 is 1.
And always
1 of each in the middle.
So if this is negative, that has to be positive, and that has to be positive. There you go.
And but also the y and the outside.
And we soak the sides. Same, opposite, always positive. We started with minus. Same,
Yeah, so the only
opposite,
we
always positive.
was the GCF. That's all we did.
All right. Are we good there?
It is. Thank you, Chad.
So let me run over this one more time. Is this making sense? So first step, you take out what's in common. What do they both have? Y squared. You put parentheses, and you put inside whatever works. Y squared times x cubed goes back. Y squared times 1 goes back. Now, this is a triple. This is x, 1, 1. So then you go one of these x's left, one of these 1's right, 2 x's left, 1 times 1, 1 right, one of each in the middle. Soak the signs. All right, we good? Okay, so use your calculator. You'll find out this is 5x, 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 6y, 6y, 6y. Then we go little parenthesis and big. So little parenthesis and big. And then we go 1 left, 1 right. So take one of these items, one of the triple items on the left, one of the triple items on the right. 1 left, 1 right. 2 left, 5x, 5x. 2 right, 6y, 6y. And 1 of each in the middle. So 5x times 6y, 30xy. Is that good? And then we soak the sign. Same, opposite, always positive. Same as what we started with, minus. Opposite, always positive. Does that make sense? I had a couple people not getting the x squared here. Is everybody getting the 5x squared? Right? Because it's 5x, 5x. Is that good? Okay, so 5x, 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 2y, 2y, 2y. Good? Okay, so now what do? We do a little parenthesis and a big, and we go 1 left, 1 right, 2 left, 5x times 5x, 25x, 2 right, 2y, 2y, 4y squared, and 1 of each in the middle, 5x times 2y, 10xy in the middle. We good there? And then soak the signs. S-O-A-P. Same as what you started with. Opposite of what you started with. Always positive at the back. Same opposite, always positive. We good? So, what do? Well, we'll do the bow tie. I'm not sure how the bow tie is going to work with frac. I've never done the bow tie is new to me. So let's see what happens. We'll learn together. So x and x. We're off to a good start. Okay, right here. Right here goes 1/25, right? Multiplies right here goes minus 2/5. Oh yeah, this is fine. What two fractions?
Yeah, 1/5 and 1/5.
1/5 and 1/5.
Minus 1/5.
Yeah, right?
Plus 1/5.
1/5 times 1/5 multiplies to be 1/25, right?
Yeah, and they are
And what signs? Both minus.
minus.
Two negatives multiply to be positive and add to be a bigger negative.
Yeah.
Did you actually?
Good?
Yeah. And then we just divide.
Are we good so far?
We don't divide, we just put it down. X minus 1/5. And x minus
The number in
1/5.
front, which is 1,
And then I go
times 1/25
square.
is 1/25.
X minus 1/5. X squared.
We good? Is that making sense?
Yes.
It's not that bad. And then the first two, what goes into them? Nothing. So x minus 1/5. Back to same thing. When you have two identical twins,
Put it together and it's squared.
squared. That's not too bad, right?
Kaboom.
Kaboom.
Yeah, that's easy, right?
Good with the bow tie? So let's, right? That means this is how you should be visualizing it. That's how you should be looking at it. That minus is the separator, huh? So you should be looking at it like that. How many terms? 2 terms. 1 term, 2 terms. What do they both have in common? Take it out. Parentheses y minus 5. Put it in the front. Okay, so what do they both have?
Y minus 5.
Yeah, do you see that? Like for example, let me make sure we're clear on this for a second. What if we had x squared w minus 36? What if it was just a w, for example? What would you do? You would say both those guys have a w, put it in the front, remove it, bring down x squared minus 36, huh? Because that w could go back, couldn't it? Well, that's exactly what we do here. It's just a bigger common piece. Y minus 5. That's like the w. They both have it. So you put the parentheses y minus 5 in the front. Start a new set. Remove it. X squared minus 36. So far, so good? We're not done yet. But that's the first step. I took out what's in common. Now, what can you do with x squared minus 36?
They keep going down.
Yeah.
It's minus.
It's a double, isn't it? It's 2 terms. 2 terms. What's the only thing we ever look for? Double, or triple. This is x, 6, 6. It's a double. Doble. All right, so then the y minus 5 stays there. He just doesn't break down anymore. And we do 2 parentheses, 1 left, 1 right, 1 plus, 1 minus. And there we go. That good? Left, right, 1 plus, 1 minus. Are we good? Have you had enough math for the week with only one